Saltwater can generate electricity through various methods that exploit its unique chemical and physical properties. Here are a few primary ways this can be achieved. 1. Saltwater batteries. Saltwater batteries use a saline solution as the electrolyte. Here's how they work. Components: a saltwater battery typically consists of an anode, a cathode, and a saltwater, saline, electrolyte. Electrochemical reaction: when the anode and cathode are immersed in the saltwater, an electrochemical reaction occurs, causing ions to move between the electrodes, generating electricity. Example: Aqueon Energy developed a type of saltwater battery that uses a manganese oxide cathode, a carbon composite anode, and a saltwater electrolyte. 2. Reverse electrodialysis, RET. RET is a method of generating electricity by mixing saltwater and freshwater through a series of membranes. Process: RET stacks alternate layers of cation and anion exchange membranes. When saltwater and freshwater are passed through these membranes, the difference in ion concentration creates a voltage, which can be harnessed to generate electricity. Steps: saltwater and freshwater are alternately fed into the stack. The ion exchange membranes selectively allow the movement of either positive or negative ions. This movement of ions generates a potential difference, which can be converted into electrical energy. 3. Salinity gradient power, blue energy. Salinity gradient power, also known as blue energy, exploits the energy released when freshwater mixes with saltwater. Pressure retarded osmosis, Pro-1 technique, where freshwater is passed through a semi-permeable membrane into saltwater, creating osmotic pressure that drives a turbine to generate electricity. Reverse electrodialysis, RET as described above. 4. Ocean thermal energy conversion, OTC. OTEC uses the temperature difference between warmer surface water and colder deep ocean water to generate electricity. Process: warm surface water is used to vaporize a working fluid with a low boiling point, example, ammonia. The vapor drives a turbine connected to a generator. Cold deep water is then used to condense the vapor back into a liquid, completing the cycle. 5. Microbial fuel cells, MFCs. MFCs generate electricity by harnessing the metabolic processes of bacteria. Process: bacteria in an anaerobic environment break down organic matter. This process releases electrons and protons. The electrons flow through an external circuit to generate electricity, while the protons pass through a membrane to combine with oxygen, forming water. 6. Wave and tidal energy. While not directly related to saltwater's chemical properties, wave and tidal energy harness the physical movement of saltwater. Wave energy: devices on or below the water's surface capture the kinetic energy of waves. Tidal energy: underwater turbines are placed in areas with high tidal movement, capturing energy from the ebb and flow of tides.